So hello guys, welcome to the Manjose Electro Hive channel. So I'm Joseph Okloeng. I'm a biomedical engineering student, and I'm going to be taking you guys through the in the previous video we talked about how a bipolar junction transistor works, the conventional current flow and the electron flow. So you guys, if you do not understand that, you can go back and please refer to the other video. I'm going to hint on some things from the previous video in this. So if you've not yet checked out the other video, please go and check it out. So today we're going to be talking about the biasing of the transistor. So there are different regions that are formed. There are about 3 regions that we have in different cases of how we bias the different materials, either the P channel or the N, in how we bias them. So we have different regions. So first of all, biasing, as you can see here, biasing a transistor is basically supplying an external DC voltage, a suitable external DC voltage. So there are 2 ways in which you can bias a junction or a PN junction. So there's a forward bias case, which is a condition when we apply a positive voltage. Let's say this is our PN junction. That's all. We're talking about transistors, but I'm using the PN junction to explain the situation. So when you have forward bias, we're going to connect a positive voltage and a negative voltage to the N. So that is what we call forward biasing. Reverse biasing is when we connect a negative to that to the P and a positive to the N. That is called reverse biasing. So moving on, as I said, there are 4 regions. As you can see here, there are 4 kinds of regions that are formed basing on the different ways in which you're going to bias that, the different junctions, the emitter junction and the collector junction. So but the inverse active region, as you can see here, the inverse active region is not suitable for any applications and hence is not used. That's why I decided to cross it out. It's not suitable for any applications. So basically we have these 3 regions, which is called the saturation region, active region and cutoff region. So you see here, the saturation region is formed when you forward bias both the junctions. Active region is formed when you forward bias the emitter junction and reverse bias the collector junction. So as you can see here, let me draw a better thing. So let's talk about the active region. So in the active region, we said is formed when we forward bias the emitter collector junction. Remember our transistor, our BJT, as you can see here, this is the emitter, base and the collector. So this is the base, this is the emitter, and this is the collector. So we're going to forward bias this junction in order to active. So the P is going to be positive like this. Then this side we're going to reverse bias it. So you can either do that by having a voltage which is greater than the base, or we can just do that by, as well just do this, connecting a positive voltage there and bring it and connect it there, all the same. So in that case we have reverse biased this and we have forward biased this junction. This is the emitter junction, and this is the collector junction that are being talked about here. So now let me use a better diagram to explain this. So last time in the previous video I actually explained to you guys how this works. So basically that means that we only did for the active region. So as you can, if you look at this diagram, here we have a positive voltage relative to the what, to the emitter. So you find that this side here is forward bias, and so electrons will just easily cross to the what, to the base. But now this side has a greater voltage V plus than the what, than the base voltage. But according to how these PN junctions are designed, you always find that the base is made small in such a way that when the electrons cross from when the electrons cross from this side coming here, since it's forward bias, they can easily jump to the collector since the base is small, though there will be some that will be going through the base junction as well. So depending on how you increase your base voltage, as you increase your base voltage, you increase the number of electrons that are jumping to the collector side. So that there's an equation that relates the collector current, which is this, to the base current. So we're actually you're going to see that. So as I told you guys, this is the electron flow conversion. Then this is showing you the conventional flow of the current. So this is IC, current IC here. The electrons are flowing the other side, then the current IC is flowing down. Then our current IB will be here. Then this will be the current IE, current IE. Yeah. So now that you have seen how the active region works, so that is basically what this diagram was explaining. Here they just use conventional currents. So as I told you guys, when you use the symbols, we always use the conventional currents, but then when you use these diagrams, we always use the electron flow to explain them. So this is the relation that I was talking about between the collector current IC, then the constant here, which is beta, current amplification factor, then IB is the base current. The saturation region is basically formed when you have when both the junctions are forward biased. So you find that all the electrons will just easily flow through from, since this is forward bias and this forward bias, the electrons will just easily flow through across. So in the saturation region, we find that our transistor behaves as a closed switch, and the effect that it has on the collector and the emitter is as though they are being shorted. That's why you can just see here that the current here IC is flowing down from the collector to the emitter, and there is no current flowing to the base or from the base. So in this case of saturation is when you as well get to see that the current IC is equal to the current through the emitter, and it's the maximum current that can flow through the emitter or the collector. That's when you obtain the maximum current flowing through the emitter or the collector, is during the saturation region, which is given by this equation. Then the last region that we shall talk about is the cutoff region. So the cutoff region operates, we can either have it when the diode is not biased. Remember, we said electrons are only able to flow through a junction when we bias it. When we bias it, that means we are giving the electrons the energy they need in order to overcome the field that is there in the depletion region. And so if our transistor is not biased, let's just say it's just like this, it's also as well in the cutoff region. There is no current, there's zero current flowing through the collector, the base, and the emitter, in the case that it's not biased. But just as well, if we reverse bias both situations, if we reverse bias the PN junction, the NPN, then we reverse bias everything. So here we shall have a positive to the negative, then here we shall have a negative to the positive. So there will be no electrons flowing from the emitter, this is the base and this is the collector. There will be no electrons flowing from the emitter to the base, and so there will be nothing, there will be no electrons trying to a jump from the base to the collector, as is experienced in this case of the active region, as explained earlier on. So those are basically that. This equation just shows you that all the currents in the transistor are zero when both the junctions are reverse biased and when the transistor is not biased, we have the cutoff region. So basically our transistor operates as a switch in the cutoff region, where it behaves as an open switch, and as a closed switch in the saturation region. So when they tell you to describe how a transistor operates as a switch, so you basically talk about the saturation region, where it acts as a closed switch, and the cutoff region, where it operates as an open switch. And in most applications we use the active region because it acts as a beta amplifier, and there are very many other things that you can do with the transistor in this region. So thank you guys for watching, and I hope to meet you guys in the next video. Yeah, stay updated. Ciao.